Hi everyone. We have here center of mass and centroids and area moments of inertia. Uh, this is center of gravity. Center of gravity is the point of the vacuum that always passes the line of action of the weight of this body, which is a single point and fixed for this body. The location of the center of gravity G with respect to XYZ axis becomes uh, center of X equals uh, integration of X dW over integration dW and centroid of Y equals integration Y dW over integration dW, and centroid of Z is equal integration Z dW over integration dW. So here we have center of mass. The definition of center of mass, it's the point at which the sum of the masses is affected. Uh, if we assume that a system contains a number of objects, each masses of them m1, m2, m3 distributed with the x, y, z level, the cluster center of this system falls at the point where x, y, z, expressed also as uh, x equals m1 x1 plus m2 x2 plus m3 x3. So as you see, this is the expressed of center of mass. uh, the term centroid is used when the conclusion concerns a geometrical shape only. When speaking of an actual physical body, we use the term center of mass. If the area or section or body has one line of symmetry, the centroid will lie somewhere along the line of symmetry. So what's the moment of inertia? Moment of inertia is the physical term that expresses the tendency of the body to resist external influences. And so here we have the moment, the rule of moment of inertia. Ix equals integration y uh, power 2 multiplying by dA, and the moment of inertia of y equals uh, integration x power 2 multiplying by dA. So to get the centroid, we use this rule. uh, and to transfer of axes, we use this rule. And here we have this question. It says determine the moments of inertia of the z section about its centroidal. So we have this z shape, and we divided it to three shapes. This is number one, and this is number two, and this is number three. So we have here the our point here. Our point is here. Uh, so as I said, this is the reference point. So we have the solution here. We have to find the area, and it's 20 multiplied by 80 plus 20 multiplying by 160 plus 20 multiplying by 80, and we have the solution here, or the result here, 6,400 millimeter. So here we have to find the centroid of x and it's equal 0, and y is equal 0 to because the center of a group 0 x for x0 and for y0 coincide with center of part 2 due to symmetry of z shape. So here we found the moment of inertia. So I x naught equals 1 over 12 multiplying by 80 multiplying by 20 power 3 plus 80 multiplying by 20 multiplying by 0 minus 70 power 2. So here we have the result, and here for moment of inertia for y. So 1 over 12 multiplying by 20 multiplying by 80 power 3 plus 20 multiplying by 80 multiplying by 0 plus 50 power 2. So here the 0 and the 0 here, it's come from the centroid. Here the centroid for y and here the centroid for x. Uh, so here we have part 2, and we don't need to calculate part 3 because it's exactly the same of part 1. So here we have part 2. It's equals 1 over 12 multiplying by 20 multiplying by 160 power 3 plus 20 multiplying by 160, so multiplying by 0 minus 0 uh, power 2, and here we have the result. uh, so as I said before, this 0 and this 0, it's for centroid. This is for centroid of y, and this is the centroid of x, and here is 0 and here is 0 because part number 2 uh, it lie in the centroid, in the center of the or it's in the reference point, the center of them, of x and of y for part 2. They are in the reference point, so they are equal 0 for x and for y. So here we have the total. It's just summation, and here we multiplying by 2 because as I said before, uh, the shape of number 1 and shape of number 3, they are exactly the same, so we didn't need to calculate them twice, so we uh, just multiplying by 2 here. So uh, here we have the result for moment of inertia of x, and here we have the result of moment of inertia of y. So thank you for watching.